Hello. In this video I'm going to be talking about graphing absolute value functions. We've graphed some absolute value functions in the past, but I want to relate it to a previous lesson about parent functions where we talked about the parent function for a linear equation. Now we're going to talk about the parent function for an absolute value equation, and it's y equals the absolute value of x. Now if you remember, a parent function is a function that when you change things in it, you come up with a similar thing or the same thing, it just moves it around a little bit. So I've rewritten this parent function with some dials on it. Remember, with a parent function you have some dials that if you can change them, change the numbers. So for instance, right now this is a 1, and this is a 0, and this is a 0. As you change these numbers, different things happen to the graph, and I'll show you what I mean by that. So right now this is the parent function y equals absolute value of x. The 1 here doesn't change it because it's just multiplying by 1. Right now adding 0 does nothing and adding 0 does nothing. So here's the parent function. Now if I change some of the values here, so if I say y equals, I'm going to keep everything a 1 right now out here. So let's say I say y equals absolute value of x plus 2. So right now I've changed this 0 to a 2. What will that do to the graph? Well, it's going to shift it or translate it up. So it's going to move it up 2 spaces to right here. Let me change the color on that so we know which one we're talking about. So you can see here's the parent function in blue. When I add 2 to it, it just has the same exact picture, it's just 2 spaces higher, and everything is 2 higher. So for an x value of 0, the y value is 2 higher. For an x value of 2, the y value again is 2 higher. So what we've done by changing this value here is move it up that amount. So what would happen if we moved it down? So y equals absolute value of x minus 3, for instance. What do you think is going to happen then? Well, as you may have guessed, it will move it down from the parent function 3 spots. Change the color on that. Okay, so now we have 3 different absolute value functions. Make sure that you're getting a good picture of this on your graph paper. You should be using graph paper to take these notes if possible. So when you add, it'll move it up. When you subtract here, it'll move it down. But that's not the only dial we have. We have another dial here that we can change, and let's see how that will affect things. Let me get rid of these, so make sure you have those in your notes. Alright, so back to the original parent function. Now I'm going to make a new one. Let's make it y equals absolute value of x. Whoops, not that. Y equals absolute value of x minus 2. Okay. So anyone want to guess what's going to happen there? Pause it, see if you can guess. That's actually going to slide it again, but it's going to slide it to the right 2 spots. So rather than going up or down, it's actually moving to the right. Let's change the color on that. There we go. So the parent function again is in blue, and when you subtract 2, it actually moves it to the right. Now, when all else fails, you can always make a t-chart and see if it's correct, but you can plug it in here. 2 minus 2 is 0, so y is 0. 4 minus 2 is 2, so y should be 2. So you can see everything is the same, it's just slid or translated to the right, also called shifted. So let's see what happens if we slide it the other way. So y equals x plus 2. Actually, we'll slide it the other way. So let me do that one. So that one's going to look like this. So the blue one again is the parent function. The purple one here is x minus 2, and the red one is x plus 2. So unlike the vertical shift, which is from this number out here, this actually does kind of the reverse of what you might guess it to do, which you can figure it out using the t-chart, but when it's added on the inside, it shifts it to the left, and when it's subtracted, it's shifted to the right. Now, the only other number we haven't messed with, so we've messed with this number and this number, we haven't messed with the number outside here. All that does is change the slope. So if I get rid of all these again, so we can imagine if we had something like y equals 2 times the absolute value of x, what that might look like. It's actually not going to be a copy of this. It starts out in the same spot, but the slope changes it. So instead of going on a 1-to-1 ratio here, like 1, 1, 2, 2, 3, 3, and so on, you'll get a 1, 2, and a 2, 4. So it actually makes it steeper. Something like that. There we go. So it makes it steeper. Same thing on this side. Let's see, 1, 2, 4, there we go. And we can change the color on that. There we go. So it still has that absolute value v look, it just makes it steeper. So you can do some of these all at the same time. So for instance, if we wanted to do y equals absolute value of x minus 2 plus 3, for instance, instead of making a t-chart, what we could do is we're going to know that it's going to be up 3, so it's going to be around here, and then it's going to shift 2 to the right. So it's just going to look like this. So let me change the color there. There you go. So without making a t-chart, we know what it's going to look like based on what the numbers are here on the dial. So the absolute value function is an example of something called a piecewise function. A piecewise function is a function that has different rules for different parts of its domain. So let me show you an example by getting rid of these for a moment. So what we see here as we graph it, the y equals absolute value of x, is that when x is greater than or equal to 0, the absolute value of x is equal to x. And we can show that. Let me get rid of the green one as well. So we can show that on this blue graph here. The absolute value of 1 is 1, the absolute value of 2 is 2, absolute value of 3 is 3, and so on. So for every value where x is greater than or equal to 0, the absolute value of x is always equal to x. However, when x is less than or equal to 0, the absolute value of x is always equal to the opposite of x. Okay? So like -1, we get 1. For -2, we get the opposite of -2. For -4, we get the opposite of -4, which is 4. So it's piecewise in that way. So let me show you an example of another piecewise function. So let's say we have a school that needs to charter buses so that you guys can go to, let's say, physics day or something, and a bus can hold 60 students. So one bus holds 60 students. So here I have a graph, and down here we'll say number of students, and then on this we'll say number of buses. Well, this is a piecewise function because for the domain between 0 and 60 students, we're going to need one bus. So all the way up to 60 students, let me choose a different color, we're going to need one bus here. And so the graph of that would look like this. And anything past 60 students, we're going to need 2 buses. So if we had 62 students, or 61 students, we need 2 buses, all the way up to 120. Okay, but if we had 60 exactly, we're at 1 bus. So that's why I have an open circle here and a closed dot here. And then anything past 120, so not equaling 120, but past it, we need 3 buses until we get to 180, and so on. So this is a step graph, which you've seen before. I think we talked about them in 6th grade. But as you can see, you couldn't really write one function rule for this. It has multiple function rules for each domain. So domain of 0 through 60, so if x is 0 through 60, y is equal to 1. If x is 60 through 120, y is equal, or 61 through 120, y is equal to 2, and so on. So that's why it's called a piecewise function. And I'll get the last one in here. Open circle, closed dot. There you go. Thanks for watching.